All right, so let's continue. We kind of started yesterday with the graphing. We did a little chart. Remember that? Yeah. Little X and Y chart thingy. Um, Talked about what were some of the key words in there we talked about? Axis of symmetry, vertex, the y-intercept, the x-intercepts, domain and range. Right, so we talked a bunch of stuff. But now what we're going to do is we're going to switch it up a little bit. Yeah, parabola, right? So basically our graph yesterday, let's listen. Basically yesterday our graph yesterday was just a basic parabola. The other class, the pre-calc class, they call it something else. They didn't call it a basic. They called it not a standard. I don't know. I don't know. No, not ordinary, but that's how you can consider it. So I forget. I'll think of it later. So when you just have y equals x squared, that's your basic everyday normal parabola. All right. You're not really doing anything special to it. It's just real kind of basic. Was debating. Yeah, let's do it. Remember I talked about the Desmos app? Yeah. All right, so I got to do this though. So I got a Desmos. I got to do this, and then I'm for my age. What are you trying to say?
Usually, like people, how are you? 60?
I'm 60.
Usually, 60-year-olds don't know how to do any of this.
Well.
You just have a youthful spirit.
That's me. I'm just Mr. Youthful. All right, here we go. Do what?
Do you take pictures like
this? Young kids, young people, I was taking pictures way before your mom and daddy ever even thought about you, okay? Not necessarily on a phone. I was taking pictures with film in a dark room and everything else. So don't tell me about using one finger to take a picture, all right? I was taking pictures with my cell phone probably before you guys were born, all right? So don't pander to me and say for my age, because I had cell phone before you even knew what a cell phone was, all right? All right. What we're going to do is this. I'm going to show you a little demonstration of Desmos, and I'm going to do a real basic one. Then we're going to switch it up. But I do want you to know how to do these by hand and not just use it on the calculator, okay? Because if I have a quiz or a test, I might say no graphing calculator, no phone or anything to use the Desmos app. All right, you're going to have to do it by hand. But this is really good so you can see it quickly, very easily on how to graph these things. So I'm going to go y equals just x squared. So hit x and then hit that a squared button, and there's your y squared graph right there. Looks like a what? Parabola. Looks like a parabola, exactly right. And you could zoom in on it. So let's see, this way. If you zoom in on it, you can click on it. It'll tell you some points. Like if you click that point right there, that's 0.00. And let's not zoom in so much. Let's go back out here to this. If you click again right there, you can kind of move it around. There's another way you could do it too with a slider thing. I barely know anything about this Desmos app. There it is. Oh, you saw it. Anyway, you saw it a second ago, didn't you? Yeah. It was right. Let's see. Well, anyway, you saw it. It was 1-1. Okay. You could keep doing that. There is a thing on here where you could put sliders. Again, I'm kind of new to this thing. There's a lot to learn. I've watched one or two YouTube videos, and there's so much to learn about this app. It can do just amazing, incredible things. But for right now, this is all we're concerned about. It's just graphing simple little things like this. We're going to come back to this app a little bit later today, hopefully. And but we're going to do some stuff by hand. We're going to graph by hand first. Then we're going to come and look at this. And this can be very useful for what we're going to talk about a little bit later. So let's go back to that. And so that's what a y equals x squared graph looks like. It's a basic everyday parabola. But we're going to do a few things with it. So this example does change a few things. So we're going to graph it by hand, and then we're going to go back to the Desmos, look at it, compare them, and see what's going on. All right? Oh, my word. I hope they're not beating her up. Should I go over there?
Yeah,
She's out of the room? They're calming down.
Because they said yesterday she walked out their class.
I talked to them in my class today. I talked to both classes about how they behave over there. All right, I'm going to go over there. Okay, back to us. That didn't take long on the YouTubes. All right, here we go. What we're going to do is we're going to graph a couple things. Actually, we're going to graph 3 of them all in the same graph, and I want to show you what they look like. Or should I do? Okay, so let's put an x first. Instead of putting a y, what did we put yesterday? We didn't put y, we put f of x. All right, so they actually, let's do this. Oops, keep that there. Let's try this again. Try that, click on that. There we go. Get rid of that, get rid of the y, and let's turn that into f of x. And what we're going to do, I don't know if I've talked about this. We use f most of the time, f of x. It's f for function, okay? But you can use any letter out here, okay? A lot of times they go in order. They go f, g, h, and that kind of thing. But you can use any letter. But this is kind of like the convention that people usually use, math people usually use. So you could say g of x. Basically what this means is it's still a function. It's just a different function than this. I'm not going to say g of x equals x squared because that's the same function, right? You guys watching? You're not even looking up here. Okay, make an attempt. Just make an attempt. It's not that hard. You don't have to look at me. Just look at the screen, all right? It's not that hard. I had a teacher in college. I took this economics class or some kind of class like that. It was something that I had to take from it wasn't even for my major. And to be honest with you, I couldn't stand that guy. He was so obnoxious. And I don't know, something about him, I just clashed with him. And I couldn't even look at him. I mean, it was that bad. I mean, I'd sit there, I might look at the board if he's writing something on the board, maybe. But I'd look at my paper. He just his face just upset me just because of the way he was. So I understand. So if I'm like that to you, that's okay. I get it. I've been there. But you don't have to look at me. Just look at what I'm writing, okay? Because this is going to help you out. All right, here we go. So I've got 3 equations. What I'm going to do is graph all 3 of these equations on the same graph, all right? And that's why we use different letters. This is my f of x function, g of x, h of x. We use different letters just to represent their different functions. That's the only reason we do that, okay? So what I'm going to do is make my little table. And today, really, this whole lesson, you're always going to graph these with a table. We're going to learn a little bit more about these things so you don't have to do a table every single time. It's a little time consuming. It's a little cumbersome. It's just not the most efficient way to graph. So, but at the beginning though, that's what we are going to do. So I'm going to make a table. So I've got x here. I've got f of x next to it. I've got g of x right here. Then I've got h of x right here. So instead of just saying x and y, since I have 3 different ones, I wouldn't say like y1, y2, y3, or y and z or anything like that. This is how we do it. All right, so I'm going to pick some points. You can pick any points you want, but I'm going to pick some points that actually that work, that stay within a certain boundary. They don't go wild and crazy. All right, so I'll just pick some nice points. Well, not me. The book's actually doing this. I'm just doing this from what the book does. But this is pretty much what I would have picked. So what they do, a lot of times I do the negatives first, then 0, then the positives. But what they do, and I kind of understand, I kind of like the way they do this, they put a 1 and a negative 1 together, and then what do you think they go to now? 2 and negative 2, right? All right, and that's enough to do what we're going to do. So let's put it into the f of x function first. So we're putting a 0 in for x. So what's 0 squared? 0. 1 squared, 1. Negative 1 squared, 1. 2 squared, now you're getting slower. 4, 2 squared is 4. And then negative 2 squared is what? Is it negative or positive? It's positive because you're squaring a negative. All right? Everybody with me on that? Yeah, that was easy. And now what are we going to do? We're going to put it into this. We're going to square it just like we did the first one, but then we're going to multiply it by 2. So basically, here's my f of x column. So really, what should I just do? Just double everything. That's right. So 0, 2, 2, 8, and 8. You with me? All right. If you wanted to, you could put the original x into here and go 0 squared is 0 times 2 is 0. You could do that if you wanted to. This is, this is now, instead of 2 times x squared, what are we going to do? We're going to take this x squared, this f of x, multiply it by negative 1/2. Well, 0 is still going to be 0, right? And then what are we going to do? Take that 1, multiply by negative 1/2. What do we get? Negative 1/2. All right, and then what are you going to get here? It's the same number, right? So that's going to be negative 1/2. Take the 4, multiply that by negative 1/2. Negative 2. All right, and then put that, it's the same number, so it's going to be the same thing. So this is what we're going to graph. We're going to graph it all on the same axis, okay? Let's see if that's still copied. It did. All right, and let's do this. Do this. And there you go. All right, and we'll use different color for each of these. I'll tell you what, I'll just, what do you want to make? Let's make that one red. All right, what do you want to make the g of x? Green. All right, what about the h of x? Purple. Okay, what purple? I got several purples. That probably shows up. Does that show up all right? Can you read that? Yeah, you can read that, all right? All right, so let's do that. Let's do the f of x first. So you just put the points in. This is kind of like x, y, right? So this is an ordered pair, 0, 0, 1, 1, negative 1, 1, and so on, all right? And we're just going to plot those points. Let's see what we get. 0, 0 is right here, all right? And then 1, 1. It's going to be kind of skinny. Yeah, I guess we got to go up to 8 anyway. How far does this go up? 1, 2, 3, 4, 5, 6, 7, 8. Oh, perfect. All right, it just happened to work that way. 1, 1 would be right here, and then negative 1, 1. And the reason, remember the reason I said I kind of like how they do this, putting the 1 and the negative 1 together? Because look, it's kind of symmetric, isn't it? If I go over 1, I go up 1. If I go over 1 to the left, I go up 1. Same thing with this. 2, 4, negative 2, 4. So if I go over 2, I go up 1, 2, 3, 4. And if I go over 2 to the left, I go up 1, 2, 3, 4. Notice, everything is above the x-axis. Why is that? Because when you're squaring something, even a negative number, you're always going to get what? A positive number, okay? Everybody see that? All right, so that's kind of interesting. Now, my handwriting, I wish they had something on this program where I could just like connect the dots and it would give me a nice, perfect, smooth curve, but I'm going to try my best. All right, it looks something like this, and then this comes around. Whoa, I got a little nervous at the end. All right, anyway, good enough. Not beautiful, but you get the idea. Oh, you know what? I forgot to do, did I? Oh, no, I did. I'm good. All right, let's do the next one. Let's see the difference. I want to see, what is that 2 going to do to this red one? I mean, this is x squared. This is 2x squared. So what do you think it's going to do to that red one? Is it going to, Lily said this. Any other? Is it going to make it wider? Okay, that's a good choice. Go wider, go skinnier. Is it going to make it go up, go down? Is it going to flip it on its side? Is it going to flip it upside down? What's it going to do? Well, let's put the numbers in. Let's see what happens. All right. So 0, 0. So we're still right there. But now, where's my points? The x was 1. Instead of going 1, 1, what's it going to do? It's going to go 1, what? 2. So what's it doing? So it makes it thinner. That's right. It makes it skinnier, thinner, narrower, however word you want to use. It makes it steeper. I think this book uses the phrase steeper. Okay. And does it keep on doing that? 2, 4. So if I go over 2, the other one went, I'm sorry, 2, 8. The other one went 2, 4. This one's going to go what? 2, 8. And this one's going to go negative 2, 8. Do you see that? It's the same shape, isn't it? But it's thinner, skinnier, steeper, however you want to use that. All right, that looks like it goes straight up. Should be kind of curved, but it's actually easier to do it on paper than it is on this thing because it's so slippery. Yeah, it's slippery. All right, so you see what happened? When this was a 2, it became steeper, it became skinnier. What if that was a 3? What do you think it would do? It'd make it even steeper, okay? Make it even skinnier. So the higher up you go, the skinnier the graph gets. Everybody see that? Yeah. All right. So what do you think? Well, this does 2 things. It's got a negative and it's got a 1/2. So what do you think that's going to do to it? It's actually going to flip it upside down. That's right. What do you think is making it flip upside down? Do you think it's the half? It's the negative. That's right. So if you graph this thing, you're going to see that that negative makes the thing go down instead of up. So we say that this opens up, right? So this graph right here opens up. Both of these do. But this purple one is going to open what? Down. Okay. And what do you think that 1/2's going to do? I kind of wish, I'll tell you what, let's do this. Let's forget the negatives right now. I just want you to see what this is going to do going in the same direction. All right. I think they should have done that and then gone ahead and done the negative, but let's do it ourselves. So 0, 0. And what's this? This is 1, what? 1/2. So it's kind of little, but it's right there. And then it's -1 up 1/2. And then the other one is 2. Oops. Yeah, we're not going negative. So the other would be what? 2, 2. I'm forgetting the negative on this one, okay? I just want to see it going up. All right, so 2, 2. So this would be -2, 2. Would you agree? And if you wanted, let's put an even number in because we're taking half of it. It'd be a lot easier. So if you put put a 4 in there. So what if you put a 4 into this? Well, 4 squared is 16. Half of 16 is 8. So if I go over 4, 1, 2, 3, 4, I'm going to go all the way up to here. And if I go -4, 1, 2, 3, 4, I'd go all the way up to here. Everybody see that? See what it's doing? Oh, there we go. Again. And going to the left is even more difficult. Oh, my goodness. Let's start again. There we go. All right. So it kind of looks like that. It should be a little bit smoother. You get the idea. All right. But that's what's happening. So look what happens. When this, and I'll tell you right now, I'm going to show you a little bit later, but when this coefficient out here is, let's do it to this first. When this coefficient is greater than 1, what happens to the graph? Gets skinnier, gets steeper, gets thinner, whatever you want to say. And then, what do you think here? As this coefficient gets what? Less than 1, all right? Because if it was a 1, it would look normal, like that red one, okay? So we're all comparing it to that coefficient being 1. If it's greater than 1, it gets steeper. If it's less than 1, it gets what? Gets fatter or wider or less steep. I don't know what you want to call it. Flatter. That's a good way to say it too. Okay? Everybody okay with that? All right, let's do the negative now. All right? So let's do that. 0, 0, 1, -1/2, -1, -1/2. 2 would be what? -2 right there. -2 would be -2. And if you wanted to go to 4, 3, 4, this would go all the way down to -8, and 4, 1, 2, 3, 4 would go down to -8 right there. And you see what it's doing to it, isn't it? Oops, I missed it, but you get the idea. Doesn't have to be perfect. I missed that one too. All right, and there you go. It's a rough sketch, okay, but that's a sketch of that graph. See what it did? So what does that negative make it do? Makes it open down. If it's positive, it would open up. Okay, if this coefficient is greater than 1, it would make it skinnier. If it's less than 1, it would make it fatter, wider. Okay? Make sense? Yeah. Serious? Did you take any notes at all? Show me your notes. If you show me notes, I'll let you go. There's no way I'm going to let you go when you're not even trying in here. Well, you're all right. No. All right. Yeah, he knows it all. All right, let's take a look at this. All right, here's what we're doing. And then I got another one, g of x. Now, we're going to do something a little bit different to this. All right? X squared. Watch what we're going to do. I'm going to add a number to it. We didn't do that earlier. Okay? And I think this may be the time where I want to Shh. Stop. This may be the time where I want to use Desmos because it just takes too long to do the chart and plot the points and try to get a good curve and all that kind of stuff, all right? So did you write this down? Write it down so when I go to Desmos, then you can see what's going to happen. So what's the only thing different between these three? Look, compare both of these to this original one right here. You got the 1/2, so it makes it a little wider than the normal x squared, correct? But so does that, because that's a 1/2. So does that, that's 1/2. So this is the same, this is the same. What's the only thing different? That number on the end, right? So what do you possibly think? Just take a wild guess. It's a good guess. It's a good guess. We're going to do that eventually, not today though. So it doesn't move it left and right. It moves it up and down. Tell you what, let's do this. Watch. Let's do a real base. Let's do that x squared one and then go +2. All right. Let's do the actual graph. All right, just to kind of see, and then we're going to go to Desmos and we'll do it there. All right. So let's take a look. What does x squared look like? Well, let's put some stuff in here. Let's go, I don't know, -2. I'll go all negatives, -1, 0, 1, 2. All right. So what is that? If it's squared, come on, guys. Come on, act like you're honor students. So what is this? This is going to be 4. It's going to be 1. It's going to be 0. It's going to be 1. It's going to be 4. Agreed? So -2, 1, 2, 1, 2, 3, 4. It's going to be right here. -1, 1 is here. 0, 0, 1, 1, and 2, 4. All right, so there's your parabola, your regular everyday parabola. What in the world does this do to it? Well, let's put the +2 right here. So what's this going to be? That's going to be 6. That's going to be 3. That's going to be 2, 3, 6. So what does that do? Well, -2 instead of -2, 2, or -2, 4, what's it going to be? Go ahead. It's -2, 6. So where's 6? 6 is way up here, isn't it? Right? 5. I don't want to change colors. So -2, 6, oops, is going to be right here. 2, 6 is going to be here. But look where the 0 is now. It's not at 0, 0 anymore, is it? Where is it? It's at 0 what? 2. So it's here. All right? And then the 1 is 3, would be there and there. You see what it's doing? It's the same exact shape, except what did it do? It just moved it up 2. They don't look the same shape because that red one's terrible. That green one's not half bad. But anyway, they're the same shape, but what did that 3 do to it? It just moved, oh, sorry, it's this one. What did that 2 do to it? It moved it up 2 places. All right, so what do you think this -4 is going to do to that graph? It would take it down 4 places, 1, 2, 3, 4. It would start here, and then it would go over 1, up 1, over 2, up 4, right? Over 1, up 1 here, over 2, up 4, and then it would look like this. Oops, that's an awful graph, but you get the idea, all right? It would just move it up and down. So let's go back to Desmos real quick. Let's get rid of that. There we go. All right, and I'm going to keep that y equals x squared there. Let's put another one on there. So let's go y equals x squared plus, I don't know, 4. See what it did? All right, so it's the same exact curve. Would you agree? The shape is the same. It's not wider, it's not fatter or anything else. Okay, but it moved it up to where? To 4. All right, if let's just copy this. Okay, what if we put I don't know, -3? Still goes up though, doesn't it? All right, so this minus didn't change whether it goes up or down. What did it do? It just shifted it. We call it translating, or shift is fine, but we translate it or we shift it up and down. You got that? So that's what the thing on the end does, okay? That number on the end makes it go up or down. How would I make that green one flip down and open down instead of open up? What would I do? put a negative out in front of it. So if I put a negative, oh, where'd it go? There it is. See what it did? Okay, it's the same graph, except it just flipped it down. That's all it did. All right. Let's do this. So let's keep these. Let's get rid of this one and this one. Let's keep that red one there. So let's, I don't know, let's just make up some numbers. Don't go super crazy, but make it a little skinnier. So what would I do to make it a little skinnier? Make it what? Give me a number. 5. Okay, 5, and then x squared. Look at that. See, it's the same graph, starts at the same place, same vertex, same axis of symmetry, all that stuff, all right, is just skinnier. That's all it is. Let's keep that same shape, well, kind of the same shape, but let's make it fatter, wider. What would I put in there? Okay, give me a number less than 1. Between 0 and 1. 0.2, good. 0.2, I heard. Look at that. That's what 0.2 does. 10 or 2/10, 1/5, right? And that's what it does. And so you could keep putting numbers in there and just compare them all day long. All right, so that's what we know how to do so far. So we know what the original one looks like. We know how to make it skinnier. We know how to make it fatter. We know how to flip it, right? Making it go down the other way. And I think that's it. That's all we know how to do on these graphs right now. So let's go back to the writing thingy. Does that make sense on what's going on here? All right, that's always good to use. So let's go back to this and talk about the equation itself. All right, do you remember what the quadratic function was? F of x. What's the quadratic function? A what? X, oops, I forgot the x. Ax squared plus bx plus c. All right, so that's a quadratic function. So what we know right now are a couple things. That a right there, that tells us something. All right, that tells us that if it's positive, a, what happens? It opens how? It opens up. All right, up. If it's negative, it opens down. If it's negative, then if it's a negative a, I'll just put the a here like this, then what's it do? It opens down. Okay? So always look for that. As soon as you see that, if you're to graph it, you should know whether it's going to go up or going to go down. Forget this stuff right now. Okay, let's just concentrate. Oh, let's do a little bit more. Let's make it skinnier or wider. So if a, it's actually absolute value of a, because I'm not going to consider the negatives, because then all the negative does is make it go up and down, okay? So if just whatever the number is out in front of it, all right, forgetting the negative, that's why I put absolute value. If it's greater than 1, what does this graph do in comparison to if it was 1? It makes it what? Steeper, right. What word did I use? I just said skinnier. Let's settle on a better word than skinny. Thinner? Is that good? Or do you like steeper or skinnier or thinner? Is there another word you could use? What do you like better? Steeper? Okay. So it makes it steeper. Everybody got that? All right. So if this number is bigger than 1, and sometimes people think it's the opposite way because they think a bigger number is going to make it wider, right? And yeah, it kind of seems like that. But a bigger number makes it so if I go over 1, instead of going over just a little bit, I'm going to go way up, which makes it what? Skinnier. You got it? All right. And of course, if the absolute value of a is less than 1, what's it make it do? Makes it wider. Or what'd you say, Lily? Did you say wider before? Flatter. I like wider. Let's use wider. Is that all right? I like steeper and wider. Okay. What about the C? The C tells us something. What does that tell us? Right. It translates it, okay, or it shifts. Let's say shifts. Is that all right? It doesn't matter. Or translate. Okay. That's what it does, which means it goes up or down. So if it's positive, What does the positive do to it? It shifts it what? It shifts up. Okay? If it's negative, then it shifts down. We good? All right. Yeah. I think that's it for that. All right, let's do an example. We'll be done. All right, we're not going to use Desmos. We're just going to graph it by hand. And I'm going to want you to graph it. Okay, I want you to graph this. I'll give you like 5 minutes. So g of x equals negative 3x squared plus 4. There you go. So this is what you're going to graph. Let's talk about it for a second before you graph it. Now, you could do a little chart, okay, for this. And what I would use the points 0, 1 and negative 1, and 2 and negative 2, right? So we're on the same page here. But what's this thing going to do to your graph? It's going to make it upside down. It's going to flip it, right? It's going to flip it over the x-axis. What is the 3 itself going to do? Make it what compared to the original? It's going to be steeper. It's going to be skinnier, whatever, okay? So you know what that's going to do. And where does it start? Where's the vertex? It's at 4, right? And that means if it's 4 here, so what's the actual vertex? 0, 4. Okay? So it's going to look like this, and it's going to look something like that. All right? But be a little bit more careful with it, I guess. All right? So go ahead and just graph it. Put some points in here. See what it looks like. And, oh, there's another. After you finish this, I'll do another word. I'm going to talk about this point right here. All right, so I gave you a couple minutes. You should have a graph that looks something similar to this. Would you agree? But let's put this, again, let's go back to Desmos, and we'll put it on there and see, oops, where am I doing? There we go. There's Desmos. Let's go back to this and try it, see what it looks like. Let's get rid of that. Let's get rid of that. I'll keep that there. I like that as just a comparison. And so what do we do? Y equals, what was it? Negative 3x squared. So negative 3x squared. Let's do this in it. And then plus 4. Okay, so plus 4. There we go. Let's change the color. Oh, let's do this. Right click. I thought I could, let's see, double click. Double click? No. How did I change the color of this? I know I changed the color of this before. Hold it. Just hold it down. All right, because that, I don't want 2 reds. Oh, forgot the negative. It is negative. Thank you. Oh, there we go. All right, so that's what it should look like. So the green one right there is what it should look like. All right. Now again, if you actually like put this equal to 0, let's see what that does. I'll keep that there. If I set this equal to 0, yeah, it actually, see, it puts the points there, and it actually tells you the value where it hits the x-axis. If you set it equal to 0, right there and right there, I think it might do that. Yeah. Let's see, I think. What's that, 2? Yeah, forget that. I don't know. I got to learn the program a little bit better before I start doing stuff like that. All right, but there's our graph right there. If you click on the graph, I think it will tell you the zeros. See that? Whatever number that is, some crazy number. So my point on this is graphing a good way to really solve for x if I had something like this? No, it would not be. All right. Now, it does cross the x-axis, so there are values, there are real answers, real value answers for x, but that'd be really difficult, especially if you're going to draw it by hand. There's no way you could get that detailed about where that x is. All right. So you'd have to do that algebraically. Just shows you that graphing it, especially by hand, definitely has some drawbacks to it. All right. So solving by graphing is not always the best way. So that kind of shows that. Shows where they intersect. That's kind of interesting, right? There's a lot of other things that can show. Again, I'm really new to this program, but the more I learn it, the more we can see what it does, and that's it. And you could learn it yourself too, couldn't you?
Yeah.
Yeah. Yeah, go to YouTube. I mean, I tell you what, there's nothing like it. There's nothing like going to YouTube to learn stuff. It's just amazing. I mean, you could really, and I've heard people talk about this, you can get a college education because I heard that like MIT like has like tons and tons of classes at MIT on either YouTube or their website or something like that that you could go to. And you really could get an MIT education. You may not get the piece of paper that says you graduated from there, but you can learn the stuff that they learn at these colleges, and it's really pretty amazing. So let's see. I got a little assignment for you. 1 to 20. So, I'm sorry, wrong class. No, that's right, class.
That's right.
Yep. 6-1A, so section 6-1A, and you're doing 1 to 20. Okay? There it is. That's your homework. And I don't believe you have to graph like every single one of these. I think they have where they ask a lot of questions like what's the vertex, what's the domain, all that kind of stuff. So that kind of takes up a lot of those questions. All right, but you will have to graph a few of these, so make sure that you got that down pat. All right, enough of that.